All right, now comes the almost magical part in this objective where we put all the stuff we've been learning together. You know how to calculate the slope of a line, and you know how to read a graph like this. This should probably look familiar. So we have here a position versus time graph, and now we're going to use this to find a sort of surprising thing. We know that for any time we can find the position, and for any position we can find the time. What we're going to see here is that you can actually use this graph to find the speed of the object. And what you have to do is find the slope of the line. And almost incredibly, the slope of this line at any given point represents the speed of the object. And let's take a look at as to why that is. Remember that slope is your change in y over your change in x. And let's look at this and look at it not in terms of numbers or anything like that, just with the units. The change in y, how much the position changes, is going to be in a value of meters. So for instance, if I start at 1 meter and go up to 3 meters, my change in y is 2 meters. So the units of that will be meters, the units of my change in y. The units of my change in x, let's say I go from 1 second to 3 seconds. The change is 2 seconds. So the units of my change in x will be seconds. And I hope at this point that unit looks pretty familiar to you. Meters per second is a unit of speed. So if we find the slope of this line, what we're really finding is the speed. And so we're going to do that for a couple places on here. Let's find the speed of this object using the slope of a line. So here we start off at a point 0, 0 and go to a point 2, 2. So in order to find my slope, I need to know how much my y value changed. The y went from 0 to 2, so that's 2 divided by 0 to 2, 2. So the slope here, and remember n is slope, the slope there is 1. So the speed of the object during this entire time while it's on this line, the speed of the object is 1 meter per second. I can do the same thing over here. For this part over here, we can calculate the slope. The change in y is 0, the change in x is 1, 0 divided by 1 is 0, or we can just remember that anything that's flat like that has a slope of 0. So here the speed of the object is 0. The object is not moving at this point, and when something's not moving, it doesn't have a speed. We can do the same thing for all the points on here. Here, the change in y, you have to be careful. This is a time where we're going to encounter negative numbers. The change in y is minus 1, minus 1, and the change in x is 1, so the slope here is actually negative 1. And that negative sign just indicates a direction. So now we have the same speed as we had here, but it's in the opposite direction. So really you can think of this as calculating velocity. For this point, it gets up here and we're at 6, 5. So if we look at our change in y was 4, our change in x was 2, so the slope here is 2, and so on and so forth. You kind of get the idea. So remember that the slope of a position versus time graph is equal to the speed. So if I want to find the speed of the object at, let's say, 5 seconds, all I have to do is find the slope of that line, and now I found the speed of that object. We can do a similar thing if instead of measuring position, we're measuring velocity. And now notice all I've changed is what I'm measuring on the y-axis. Now I'm measuring velocity. We can use the same idea to determine what the slope of this means. It's a change in y over a change in x. My change in y is now going to have units of meters per second, and the change in x is still second. So really this boils down to units of meters per second squared. What this tells us is that the slope of a velocity versus time graph gives us our acceleration. And so now, if I look at this and it's a velocity versus time graph and the slope is 1, that means I have an acceleration of 1 meter per second squared. Here the acceleration is 0. Remember, acceleration is just how much your velocity is changing. Here the acceleration is negative 1 meters per second squared, and so on and so forth. So the big idea from this is that if you are given a graph, the slope of that graph has meaning. If it's a position versus time graph, the slope tells you the speed. If it's a velocity versus time graph, the slope tells you the acceleration.